This is your chapter number 14. Chapter number 14 is communication technologies. And in this chapter, we need to discuss the different types of networks. We need to discuss their characteristics. We need to discuss their uses. We need to discuss their advantages and disadvantages. After that, we are going to discuss different components of networks and different types of network servers, understanding the characteristics of cloud computing, data transmissions, bandwidth, data communication, packet switching, network protocols, data transmission medium, wireless technology, all of that. So this chapter is related like when you are sending data from one place to another, or you can either say that this chapter is concerned about your communication technologies. So communication happens when you have one or two computers connected together with each other. This is communication. But in terms of communication, we need to discuss in detail, like for example, we have LAN, we have WAN, we have some methods of operations like this. So if I give you the basic concept or the introduction of this chapter, it's like in the earliest of the times I used to have only standalone computers. Standalone computers means that those that are not connected to any of the server, or those that are only working in the single area. But until 1990s, like most computers are like found in your homes or even in the workplaces as well. They were standalone ones. Like they were not used to connect with other computers. And when computers are connected together, a network is created, right? That means that it is like simple when you are connecting two computers with each other. So a network, what is a network? A network is always formed when you connect one or more computers together to communicate with each other, to share data with each other. Like what is the primary reason for connecting two computers together is mainly because we want to share the data, we want to share the resources, we want to communicate with each other, or maybe in an organization if I want to connect with the thing. So when I'm working with the network components, so I have the structure of the network protocol. I have the network structure. So there are some various protocol used that are used for the efficient transfer of data. Efficient transfer means that when your data is being transmitted from one place to another, you make sure that your data is not corrupted or your data is not like lost following a data transmission. For this method, we are going to discuss 14.1, which is fundamental network model. So this is going to give you an in-depth knowledge that how your network is built it upon. So maybe in your exam, if you have a question related to TCP IP protocol, so you can easily reply to that. So the first part of the network fundamentals model is definitely the TCP and the IP protocol model that follows your OSI, Open System Interconnection model. That means that both outline rules and standards about how communication should take place, and each one is split into several layers as well, so that layers can work independently and they can function independently. It's really easy, like when you break down your any program maybe into different layers, so it becomes really easy. So when it comes to an OSI model, it has 7 different layers. So you need to remember all of these different layers. What is an OSI model? It is the model behind your network communication that is going to help you with your connectivity. So the first layer in your OSI model is going to be your application layer. This is the first layer that is going to be here, and this is the top layer that is going to directly interact with the data from the user. So when you have software applications such as web applications, email clients, they rely on this application layer to function, because this layer is responsible for managing the protocols that allows the meaningful data to be presented to the user. That means that all the data that is being presented to you in terms of networks and communication is the responsibility of your application layer. The second part is your presentation layer, and as the name says, like it is responsible for preparing your data ready for use. That is an application layer. So this can involve like translations, this can involve encryptions, this can involve compression as well. It makes sure that your data is translated into a form that is understood by the receiving device as well. The third layer is the session layer. So this is basically responsible for opening and closing communication link between devices. Like as the word says, session. So whenever a communication link is sent to you and the communication link is opened, so there is like throughout the session. Like for example, I gave you my Zoom link, and the Zoom class is going to be conducted. So it is called a session, right? So there is actually a time that is 10 of yours. That means the session has started, and maybe like around 10:40 or 10:50 something, the session ends. So the session layer is basically responsible for opening and closing the communication path or the communication channel between your transporter and between your network layers. Then I have the fourth part, which is the transport layer. So transport layer is definitely responsible for breaking down your session layers into segments so that these segments are given to the network layer. So they are basically responsible for reassembling your segments into your devices. You know it when I transmit the data from one device to another, it is always broken down into data packets. That means that your transport layer is going to be responsible for breaking it down into packets so that it can be sent from one place to another. And you know it already that when the data is being sent, it reassembles itself, right? The network layer is going to be responsible for taking the segment from transport layer and making it into small packets. So if you want to make it into small packets, it is going to be the responsibility of network layer. But then sending those small packets and then reassembling the data is going to be the responsibility of your transport layer. Data link is responsible like with a much similar role with the network layer, but rather than transmitting the data from network to network, it is like responsible for from sending data from one computer to another. And the last one is the physical layer, which involves the physical equipment that is used to transmit the data. So as an overall, this is your OSI model. The first layer you have is the application layer, the top one in hierarchy. Then you have presentation layer, you have session layer, you have transport layer, you have network layer, you have data link layer, and you have physical layer. And some of the commonly used words are like packets. What is a packet? This is basically a small unit of data in your transmission. And what is a router? A router is responsible for sending data packets to a destination outside the current network. What is a switch? A switch is the one that uses your computer MAC address to send data to a destination within your computer system. So these are some more functions that are relatively the same one, like application layer, transport layer. You can go through them, and then I have the structure of data packet. So whenever you have the structure of data packet, it's like divided into three parts. You have payloader, you have header, you have trailer. So the packet of the structure, like the prime function of the data packet is to transmit data from one device to another, because it basically breaks down your data into small packets. So a data packet is like the smallest unit of data that has to be sent from one network to another. So these elements can depend on your network and it can be used to be sent. So for example, if you have header, the header is going to contain the IP address of the sender, the IP address of the receiver, the sequence number, and the MAC address. The payload is going to contain the actual data that has to be transmitted. And then you have a trailer. A trailer is going to tell you that this is the end of the data packet, the data has reached successfully, and if there is any error checking method. So in data packet structure, you have three things. First is your header, second is your payload, third is your trailer. And here's the difference between IP address and MAC address as well. Like IP address is an address which is given to your device when you connect to an internet, and MAC address is one which is given to you by manufacturer. So IP address can be changed, but manufacturer cannot be changed. So let me share with you the questions of this layers in TCP IP protocol. So 9626 TCP IP protocol. This is the paper. Uh, okay, so here's the question. The question says that the OSI model and the TCP IP reference models are used to describe communications in network. You need to describe three similarities. You need to describe that three differences. Can you share any answer if you have any? You need 6 points. Three is going to be similarities, three is going to be differences. No answers? Okay, no problem. I'll share this question with you with A2 level chapter number 3. This is the question, and this is the answer. First of all, the similarities. These are the similarities that both of them use a logical framework for defining your network standards. Framework means the way to like a pattern to send your resources from one place to another. Both of them has a layered structure to describe or standardize the function. That means both of them have specific rails for each function. Each layer only defines and describe a specific function. Complex functionality is divided into simpler sections for easier outstanding. Existing standards are referenced by a layer or functions of layer. You can also define standards functions that allow manufacturer to create and produce components. So these are the similarities between the TCP and the IP protocol. Then here's the B part, like what are the differences? So an OSI model has definitely 7 layers, but TCP IP has 4 or 5 layers. I think here's the difference, right? Like all of these layers are the one for the TCP IP protocol, and sorry, this one, all of these layers are discussed with you. These are the layers of an OSI, and these are the layers of the TCP IP. So you can see that in TCP IP you have the again the application layer, and pretty much they perform the same operation. Like in the TCP model, this layer is condenses the role of application presentations and session layers. So you can take any point from here. Transport layer is like responsible for maintaining end-to-end communications. Network layer is like responsible for breaking down your data packets and transmitting them. Then you have the link layer as well. So OSI model and TCP IP model, both of them are important. Okay, here it is. Another question for data packets. Here it is, another question for data packets. Now this question says that you need to compare the use of static and dynamic routing when sending data packets through IP address. Static and dynamic routing, we are going to discuss this later on, but I'm sharing this question right now. Like routing is like transporting your data packets from one place to another. So you make sure that they are correctly routed. Here we have the example. I have the similarities and the differences. Similarities and differences, like similarities are it is used in routing. Routing means that when you are sending data packet from one place to another, it creates an algorithm of the forwarding table. Difference is that static routing table created by network administrators, where dynamic routing is created by algorithms. Static does not automatically take into account network, but dynamic creates a table of routing. Statics are fixed, whereas dynamic allow packets to take different routes like this. These are your similarities and differences. Here is another question for data packets that says that it shows a diagram of interconnected networks that use internet protocols. IP to communicate, a file is being sent, and you can see 6 data packets from network A to network H. Nodes B to G are routers used to connect the network. Explain why the packets arrive at network H in different order from where they were sent. Because whenever you are sending the data, they are like deassembled, and when the data is received back, they are assembled back. So this is the reason you need to write for 2 points. Then B part says that explain the role of the router. The role of router is that it is responsible for sending data packet from one place to another. It makes sure that your data reaches the accurate destination. Here is the answer. You can take help from this later on. All right. So now we are done with data packets. We are done with OSI model. We are done with TCP/IP protocol. Do you have any confusion still right now? The next part is transmitting data packets. Now, when you want to transmit data packets, you have two methods. One is circuit switching and one is packet switching. And in your syllabus, you need to have an idea. You should must be having an idea about them. So let's take a quick comparison between them regarding circuit switching and packet switching. All right.
Hello everyone. In this video, we're going to be talking about the difference between circuit switching and packet switching. But the first thing we have to discuss is, well, what is switching? Well, switching is a process of data being transferred from one device to another. And these are the two methods that devices use to exchange data between them. So let's first talk about circuit switching. Now, circuit switching is a method where the communication happens through a dedicated circuit or channel that is created between two devices. Circuit switching is connection oriented, meaning that a connection is established before any communication takes place. And then once the connection has been established, the channel remains dedicated to that particular session. So no other devices are able to use that channel until the session is complete. But once the session is over, the channel is terminated and then made available for other devices to use. Circuit switching is primarily used in telephone systems that utilize a dedicated physical path. So in this example, we see data going from the sender to the receiver along the same dedicated path to the destination. And as the data travels, it travels in the correct order. And because they travel in the correct order, there is no need for the receiver to do any kind of reassembly to make the data readable. Now let's talk about packet switching. Now, packet switching is a method that's used on the internet where routers are used. Now, unlike circuit switching, packet switching is not connection oriented. It is connectionless. So no session or channel has to be established prior to data transfer. So as a device sends data, the data is broken down into individual packets, and then those packets will individually and independently make their way to the destination. And since they were all independent, they will take different routes to the destination as they travel, which also means that they may not all arrive in the correct order. But once the data packets reach their destination, the receiving device will reassemble the packets in the correct order so that the data can be read. Hey guys, before we continue, I just expand or
Here are the differences.
subscription. So let's talk about some of the major differences between the two. Now, in circuit switching, the quality and stability of the communication is better, which makes it better for voice calls. Now, packet switching can also do voice data, which is known as VoIP or voice over IP, but it's not as good as circuit switching. However, packet switching is more flexible because in addition to voice, it can carry a lot of other applications, such as video, web data, and email. Another difference is that in circuit switching, there is low latency because the bandwidth is fixed. A certain amount of bandwidth is allocated for each session until the session is complete. However, the disadvantage of that is that because the bandwidth is fixed, it is not used efficiently because the sessions don't completely use all the bandwidth available. But in packet switching, the bandwidth is not fixed. Instead, it changes dynamically depending on the demand, which could result in higher latencies. But packet switching is more efficient in using bandwidth because it only uses what it needs rather than a fixed amount. And another difference is that in circuit switching, the data travels in the same dedicated path in sequential order, while in packet switching, the data travels independently and will take different paths to the destination, and they may not arrive in sequential order. And finally, in circuit switching, the circuit or channel is unavailable for anyone else while in use. But in packet switching, there is no dedicated channel, so there is no waiting for a channel to open. The packets move freely, choosing various routes over the internet. So guys, I want to thank you for watching this video.
As I discussed in the circuit switching, there is a direct path, direct link between sending device. There is dedicated paths in circuit switching. So, but in a packet switching, you do not have a set path. You do not have a certain way. It keeps on changing from one and another, and it finds out the fastest way available. Then we also have the concept of method switching as well, which is like an intermediate method between circuit switching and packet switching. It is like circuit switching in that all the data packets are sent along the same path, but it is like packet switching in that any path from computer A to B can be taken. Into these, you have also the option of connectionless structures as well. You can go through them like a connection oriented part of packet switching. It's the first method is the frame relay. In frame relay, your data is separated into units that are called frames, and then these are sent out. You also have the TCP method as well, in which your connection is created and maintained until the application software at endpoints have finished exchanging data. Then you also have the example of connectionless as well, where you can give the example of Ethernet, IP, or UDP. Like these are all connection methods that you can connect with the help of using packet switching or circuit switching. If it is an Ethernet, so Ethernet is the one with a wide connection to form a network. An IP address is the protocol that you use that is like responsible for sending data from one place to another. UDP is one of the another protocols. Other than that, in the network structure parts, the first example is peer-to-peer. Peer means friends. So when I'm sending data from one computer to another, it's like I'm sending data maybe from one friend to another. And this is really simple because you only have two computers connected with it. So it can be able to use like hundreds of computers connected, but the main reason that peer-to-peer network is connected is only to share data, because a peer-to-peer network is a decentralized structure. Decentralized structure means that anyone who wishes to share the data, so like no server has the authority to control over it that what type of data is being shared. So neither they can authorize it. So peer is like a computer with equal importance who can share the data. The advantages are that it is very cheap. You don't need to buy expensive server. It requires little technical knowledge. Your user can share resources. It often has less traffic. And disadvantage that if the one computer is accessed by another computer, it can affect the performance. So data stored on each pair is not centrally backed up as well. And the files can be disorganized as well. Other than that, I have another example of the client to server model. Other than the peer to peer, now in the client to server model, you have a client and a server. A client to server model is like a combination of basically the service provider who is your server and the one who is making use of that service, that is going to be a client. So the server is going to like serve the request of all of those central points and control all functions of your network. Like these are some examples of your client to server of example. Like first of all, you have the file server. If you want to like work with a website or with an organization, you must be having a file server to share your files. You have the web server as well. Web server is used to store, process, and transmit web pages. You have the mail server as well, which is used to send and receive emails. It can store incoming emails. It can forward your request. You have the example of application server as well, which can be used to run and software applications. You have print server as well, which can be used to print the commands. You have FTP server as well that is used for file transfer protocol. This is an example of a data transfer. If you want to send files to a server, you have proxy server as well that acts as an intermediary server between your client and server. Virtual servers are also an example of that, but they are created using a virtualization software on another server. That means that you basically do not have hardware with it, but they are virtualized with a physical server. Virtualized means that they do have a physical server, but they are virtualized. Like you maybe can have one server, but based on that one server, you have virtualized many of them. So here are the advantages and disadvantages of client to server model. Advantage can be file can be located in single place and backed up on regular basis. Since you have a server, it's much securer. The level of access can also be applied to resources as well. Disadvantage that it is very much expensive. It's expensive to set up the knowledge, and failure of server will mean you will definitely use your files. Then we have LAN and WAN. Should I skip this part? Do you know it already? It's really easy. You can just go through it. Should I skip this part or do you want me to take you through it? LAN is local area network, which means geographically small. WAN is wide area network, which means wider in range. So you can contrast their like differences, like which one is better. Like if you are from an organization, so WAN will be better. If you are working for like from your home, so a LAN would be better. Then you have the VPN as well. VPN stands for Virtual Private Network. This means that you can access sensitive data from a remote location, so it makes your data much securer. With a VPN, your data is encrypted, so even if it is intercepted, it becomes meaningless. And with a VPN, if the data is intercepted or hacked between your computer, the VPN server, the hacker would not know the final destination of the data, because it like disguises yourself. The advantages of VPN is that your data is encrypted and your identity is kept private. Disadvantages that in some countries it's controversial or illegal, and it can be used for the criminal activity as well. Then the next part I have is the mobile networks. Mobile networks are like cellular networks. They are the example of the wireless wide area networks that can be used to like transmit and receive communications. We have the example of 1G, 2G, 3G, 4G, 5G networks, which offers you different supports. You can go through the advantage and the disadvantage part. Advantage like they have enabled users to communicate with each other. The disadvantage that their quality can vary. Okay, so now I'm sharing the past papers of this one, and I have completed almost half of the chapter.